Now let's talk about the stretches and compressions of functions. To begin with, there is a Desmos activity in Google Classroom that I'd like you to go and give a try. In there, you should be able to find also some notes. They'll be written on the slides that have the title Conclusions. So make sure that you get those copied down. Once you're done that Google activity, come on back to this video. Okay, so hopefully you were able to see that depending on a number that's being multiplied either to the whole function or multiplied directly to the x value, that we end up with some kind of vertical or horizontal stretch or compression. So if we have a function f of x is equal to, for example, the square root of x, and g of x is equal to a times the square root of x, notice that the a is outside of the expression, and therefore it's going to be vertical. Now, if a is greater than 1, so, excuse me, 1.1 all the way up to wherever, then that's going to cause a vertical stretch. And if a is in between 0 and 1, so like 1/2 or 1/3 or 0.28 or anything like that, we get what's called a vertical compression. Now, we don't talk about when a is less than 0, because that would be a negative number. And a negative number, of course, the negative just means there's a reflection going on in your x-axis. So we're just worried about the actual a value. Is it in between 0 and 1, or is it greater than 1? That will tell us whether or not there's a vertical stretch or compression. Now, when we talk about how much is it stretched or compressed, we can say by a factor of a. So if the number, for example, was a 3, then we would say it's a vertical stretch by a factor of 3. Same with the vertical compression, it's by a factor of a. So if a was 1/2, then we would say it's a vertical compression by a factor of 1/2. That's how much it's being compressed. Now, if the number is on the inside of the expression, it's going to be horizontal. So in the case, and this is a little bit different, if b is greater than 1, then we say it's a horizontal compression by a factor of 1 over b. So for example, let's say b was a 2, so it was the square root of 2x. Then I would say, oh, that's a horizontal compression by a factor of 1/2. Okay, notice that the number, it's always 1 over, it's a reciprocal. Same thing if it's in between 0 and 1, then it's a horizontal compression. Sorry, horizontal stretch by a factor of 1 over b again. So let's say I have the number 1/2, 0.5. So if I go 1 divided by 0.5, that actually equals out to 2. So it's a horizontal stretch by a factor of 2. Okay, this one is kind of the harder one to remember. I'm going to put a little star by it because it's always the reciprocal. It's always 1 over whatever the number is. And then from there, you can look and see if it's a compression or a stretch. All right, so describe all the transformations for each function and explain how the coordinates of the points would change. So this 5 in front, we have 5x cubed, so that's being multiplied to the whole x cubed function. So this is a vertical stretch by a factor of 5. And how it actually changed the points is we multiply the y values by 5. Okay, so since it's going to be a vertical, if you think about vertical, our y-axis is vertical, so it's changing our y values. Okay, g of x equals 1 over 2x. So that's the same thing as saying g of x is equal to 1 over 2 times 1 over x. And so we're multiplying that whole function 1 over x, that rational function, by 1/2. And so this is going to be a vertical compression by a factor of 1/2. And again, because it's out front, it's being multiplied by the whole function, then this is going to be multiply the y values by 1/2. Okay, h of x equals 1/4 x. That 1/4 is out front. There we have another vertical compression. By a factor of 1/4. And this is going to multiply the y values by 1/4. And last, we have a 1/3. It is inside the brackets, inside. So this is going to be a horizontal stretch by a factor of, okay, 1 over 1/3. Okay, so remember it's always 1 over, so 1 over 1/3, which actually equals out to 3. We are going to end up multiplying the x values by 3. Because see how 1/3 is on the inside being multiplied directly to the x. We multiply it by the factor, and the factor in this case is always 1 over b, so 1 over 1/3, which equals out to 3. All right, so let's keep going with this. Let's say we have this function, f of x, and we want to graph f of 2 of x. So I'm going to start with my 4 points that are on this graph, so I can create my table of values. And I have -6 and 4, -4 and -5, 4 and -3, and 6 and 8. Okay, so we have to look. We see that 2 is on the inside. Since it's on the inside, it's going to be horizontal. Anything horizontal, of course, happens to my x values. We're going to multiply this by the factor. So it's always 1 over b. So 1 over b would equal to 1 over 2. So we're going to multiply everything by 1/2. And when I multiply everything by 1/2, I get -3, -2, 2, and 3. So my new points are going to be at -3, 4, -2, -5, 2, -3, and 3, 8. All right, so let's see how this looks. So this we're saying is a horizontal compression by a factor of 1/2. So it's like we're taking it from either side and kind of squishing it in horizontally. So my first point is going to be at -3, 4. My next point is at -2, -5. And then 2, -3. And then 3, 8. And then let's connect these dots. So just a sec here. There we go. And if I take a look at this, it does look like I kind of took If I put my hands on either side of the graph and pushed them in, squished it in, it's exactly what it looks like. So we can see our horizontal compression happening. That looks great. Okay, what if I had a cubic now? So a cubic, I'm going to start with my base graph. -2, -1, 0, 1, 2, -8, -1, 0, 1, 8. And then again, whenever we're trying to apply our transformations, we want to start to the left and read to the right. And every number that we encounter, we want to deal with. So the first transformation I see is 0.5. It's being multiplied to the whole function of x cubed, which means that I'm going to multiply all these points by 0.5. Okay, so -8 times 0.5 is going to be -4. -1 times 0.5 is going to be -0.5. 0 times 0.5 is 0. 1 times 0.5 is going to be, 0.5. And 8 divided by 8 times 0.5 is going to be 4. All right. And then the next thing that I encounter is that +3. So now I have to deal with the +3. Again, this is moving it 3 up. And this was a vertical stretch. Nope, a vertical compression. Sorry, because it's less than 1. So vertical compression by a factor of 0.5. Okay, 3 up means I'm going to add 3 right here, and I get -1, 2.5, 3, 3.5, and 7. So my new points are going to be -2, -1, -1, 2.5, 0 and 3, 1 and 3.5, and 2 and 7. Okay, -2, -1, -1, +2.5, 0 and 3, 1 and 3.5, and 2 and 7. And this is what we get. So I have something that's vertically compressed. So we've kind of like flattened it down and then moved it up 3. So there we go. Looks great. Okay. What about if I have the absolute value? So absolute value, of course, is -2, -1, 0, 1, 2, and then 2, 1, 0, 1, 2. Now that 3 is on the inside. Since the 3 is on the inside, remember we're reading it this way. First number I encounter is the 3. So that is going to be a horizontal compression by a factor of 1/3. Multiply everything by 1/3. All my x values. Oh, this is not going to be too pretty. So that's -2/3, -1/3, 0, 1/3, 2/3. Whew. And then I have -5. So this means down 5. So over here to my y values, I'm going to subtract 5. So 2 becomes -3. 1 becomes -4. 0 becomes -5. 1 becomes -4. And 2 becomes -3. All right, so here are my points that I'm going to use to graph. All right, so let's plot these points. -2/3, so that's not even to -1. -2/3 and -3 is like here. -1/3 and -4 is, let's say, here. And 0 and -5 is here. 1/3 and -4. And then 2/3 and -3. Wow, that is definitely horizontally compressed. I mean, it is pretty tight. So again, think of it as if you came in on either side of that absolute value graph and squished it in. And then, of course, it was moved down 5. All right. Whew. Well, we're looking at our square root graph. I can see that great big square root. So let's do square root graph. Negative. Nope, not for square roots. We go 0, 1, 4, 9, 16. And that gives me 0, 1, 2, 3, and 4. I have 1/3. So this is a horizontal stretch by a factor of 1 over 1/3. So that means I want to multiply all my x values by 3. So I get 0, 3, 12, 27, wow, and 48. And then I see I have this plus 5, but it's inside the brackets. So that's actually going to go 5 to the left. I just clean that up a little bit. 5 to the left. So again, over here on my x's, I'm going to subtract 5. So I get negative 5, negative 2, 7, 22, and 43. Okay, so I don't think I'm going to get all my points on my graph here, but that's okay. This will at least give us an idea. 7 and 2, 22 and 3, and 43 and 4. Okay, so negative 5 and 0 is here. Negative 2 and 1 is here. 7 and 2 is up here. So the rest of them I'm not going to get, whoops, onto my graph, but that's okay because I have it here in my table of values. Okay, so the big thing when it comes to graphing multiple transformations is just approach each one individually. Start from the left, work to the right. So if you could practice this, page 120, questions 3, 4, and 6, that would be wonderful. And again, anytime you have any problems, reach out.